Okay, here we have a workup potential energy physics problem, and a truck has a brake failure, is falling from this easy mountain, and initially the truck is moving downhill at speed v0, and after carrying downhill a distance L with a negligible friction, the truck's driver steers a runaway vehicle into runaway truck run from an upward slope V. So like this. Essentially, we have two moments. The moment one, when the truck is moving downwards, ¿sale? Stage 1, and stage 2 when is slowing down the movement and coming up this truck down. So we have to analyze by energy methods. Now we must set the energy equation: kinetic energy 1 plus potential energy 1 plus another work equals to the second stage kinetic energy 2 plus potential energy 2. Internal energy is another thing. But so for the first stage, we can set the kinetic energy 1 is a simple one because we have everything: the mass, velocity, v0, and we complete the whole formula. But for potential energy 1, we need mass, gravity, and some variable like this is the height of this icy road at the moment of the carrying. So we can make a simple but powerful diagram. This is the slope. Okay, it's not slope. Lots of the students ask me why we don't have kinetic energy in the second stage. Because the second stage contemplates the final moment when the truck, viewed as a particle, has zero velocity. So now in zero velocity we don't have kinetic energy, but we have potential energy. We have to calculate, which is calculated by the same triangle but in opposite direction. I'm gonna draw a triangle like this. We have the height. We have distance x is the final distance, and we have a beta, whatever you want to pronounce it, angle. So potential energy is the same: mass, gravity, and this height. And the height can be calculated like maybe cosine this. So sine of beta angle is the same, opposite side x, and not h, h over x. Now the potential energy 2 is mass, gravity, and x sine of beta. Now we have K1, potential energy 1, K2, potential energy 2. We need this another work. What is another work? If we analyze this diagram, this figure, we can now in the downhill path we have zero friction, but when we are coming up this ramp, we have a kinetic coefficient of friction. No, we have some friction like this. Not in this direction. We have in the opposite direction of the movement like this. So this friction that works in opposite direction of the movement has to be considered like other work. Now we need to settle this, and we have to take this in account. Now friction of the ramp is equal to the ramp friction coefficient mr, like the normal of the ramp. I'm going to do this free body diagram for making more clear or clarify these calculations. We need the friction component, or the normal component here. This draw a triangle, and now we know this side is m cross gravity. This is the name of this side, and we need to calculate this side. So we know the angle like this, beta, and we can have the angle, the magnitude of this side of this force is mg cosine of beta. This is the same like this normal coefficient, or it's a common mistake. No, we don't need this component. We have two components. We have this component is the x component of normal, which is useful, which is purpose. We need the real normal. It's like this. I'm gonna draw it like this. This is the real meaning of the normal. Okay, like this. Okay, the arrow, yeah, like this. We need this component because it's the real normal, the normal that is supporting the truck in this very high point. So, what is the magnitude of this component? We have two components for this rectangle. We have this component. I have to erase this. I don't know how to erase this. But now we have this figure, and we have a problem called find the friction. So this is the real normal component, which is determined by this component. I'm not very good at drawing, but that's beautiful. So this is a real beta angle because by trigonometry we know this. Now the normal, this is a real normal because it's the component we need for the formula. Now adjacent side we have here is W, and we can calculate this opposite side like mg cosine of beta angle. Now we can, with this reasoning, we can settle down the new expression like this: mu r by the normal, which is mg cosine of beta angle. Beta is not my best letter. So this represents the force. We need the distance for the another work. The work is force by distance. The force is mu r mg cosine of beta for the distance, and the distance is the distance x. We know this x, or we settle down before this x. I cannot erase this dot like this. We have the right expression. Now we can settle down the whole expression. K1 plus potential energy 1 plus another work equals to the stage 2 variables. So it remains like this. We have K1, kinetic energy 1, mass, zero velocity, or V0. It not means that it's zero, it's that velocity is not set in the problem. We only want to set the variables here. Potential energy is plus mgl sine of alpha plus the other work that is in opposite direction of the movement, which is negative. By the way, is mgx sin beta. That beautiful beta. Now plus equals to the second stage, 0 plus mgx sin of beta. What was the question? What is the distance of the truck moves off the ramp before coming to a halt? Now this means this distance, I don't know what I'm doing with OneNote application, but now we now settle this distance, final distance, like x. And we have x here. We have to solve by algebra. And final expression. So, why I'm speaking in English? Because I don't speak in English with anybody. That's the first reason. The second reason is because I need to practice my English. I am very bad pronouncer of English. And the third reason is that I am forgetting something about communicating myself. I need to prepare myself for another double exam, and I need to practice in each moment of my life. Most of my life is giving and teaching classes. Giving classes in Spanish is not the same as teaching, but I am an university professor and I have to get along with this dynamics. So you can make some questions in my channel, in my social network, and I'll see you later. Thank you.